Is Ritesh here, and in this particular video, we will cover a very important topic or very important technique in our machine learning, which helps a lot in improving the performance of our models. So, there are some cases where we can have a very large number of features while after featureization. Suppose after featureization, we get a very large after featureization, we got very large dimension for our dataset. Now, working with large dimension of data set is not very feasible or very easier to work with. So we have to come up with some techniques which will help us in selecting those features that are most important in solving our problem. Suppose for a classification problem, in classification problem we will try to get those features only while training that will help us most in classifying our point into some class. So now, how to classify or sorry, how to select most important features? So there are two techniques. The first one is forward feature selection. Forward feature selection, and the second is backward backward selection. The second is backward feature selection. This is backward feature selection. So there are two techniques. So both the techniques are equally powerful, and both the techniques takes a lot of time. So let me first mention this. Both these techniques takes a lot of time. Okay, so first we will see how to use forward feature selection. Forward feature selection. Hmm. Suppose after vectorization we got n features, and this was f1, f2, f3 until fn. We have n features in total after vectorization. Now how to select which feature is the best? So in step one, what we will do is we will take the data and we will take one by one all the features. Suppose in the first step we will take f1 feature and we will see what was our accuracy. We will note it. We will see, then we will take f2. If the accuracy improves, this means that f2 is more important than f3, and so on. We will get, and we will go till fn. Suppose out of n features, f20 was giving best accuracy, or any metric. The best metric was for f20 feature. Then what we will do in step 2, is we will have f20, and then from n minus 1 feature, since we have removed one feature, from n minus 1 features we will repeat step 1. We will take one by one all the features and we will see, after combining that particular feature or using that particular feature along with f20, what was the maximum accuracy, and we will select that particular feature. And suppose f10 gave the best performance along with f20. When we used f10 along with f20, we had the best performance. Then we will select f20 in our set. Now in step 3 we will select the best feature from n minus 2 features along with this, and so on. We will go until we reach our desired number of features. Suppose we only want 50 features. We only want 50 features for our model. That's it. We have decided that we will take only 50 features out of, suppose there are 10,000 features. We have decided that we will take only 50 features once and all. So we will take top 50 features and we will do these 50. We will carry 50 steps, and we will, at the end of 50th step, we will have 50 features, and that's all. So this is how we select features, the most important features, using forward feature selection. Now let's see how backward feature selection works. What we will do is, we have all the n features. What we will do is, we will remove one feature. And we will see the drop in the performance. And then we will place it again and we will see the drop for other features. So we will do this for all the features, and we will remove that particular feature for which the drop was minimum. Why minimum and why we are removing that? The simple logic is, if by removing a particular feature fk the performance drop is very less, this means that this feature was not important in solving our particular problem. Simple logic. I will repeat it again. If by removing a particular feature the drop in performance is very less, this means that this particular feature was not that much important in solving our problem. That's why the drop is very less, no? Otherwise the drop would have been very high. So in this manner, we will keep on removing the features until we reach the desired number of features. So this is how backward feature, backward feature selection works. So these are the two techniques that are used for feature selection, and let me mention it once more. Both these techniques takes a lot of time because we have to train our model for every features. Okay, and in order to save time, suppose you have a very large data set and it contains suppose 100 million data points. So what you can do is you can take just 1 million data point and you can do feature selection on that particular 1 million data point, because after sampling 1 million from 100 million we will have almost similar distribution of all those classes of points. Suppose we have three classes of points in 100 million, and when we sample 1 million points from 100 million, we will have the same distribution of classes here. So we can do feature selection on a smaller data set, and then we can replicate this on the whole data set while training our final model. So I hope I have made it very clear till this point how to do feature selection in machine learning. So now we will stop here, and if you like my video, then please hit the like button and do consider subscribing to my channel, because I will be posting 10 to 12 videos every week. So in order to make you aware or make you or provide best content to you, so that you can learn machine learning in a genuine and very faster way, and do consider subscribing to my channel. And thanks for watching my video, and I will see you in the next video, where I will also be taking up other real world problems that we face while training our model. And so thank you for watching my video.